The Building and Construction Authority, or BCA, is conducting an independent investigation into the Tanjong Katong sinkhole that swallowed a car on Saturday. It will include soil and rock analysis by BCA and its appointed consultants and could take several months to complete.
The investigation will examine the circumstances leading to the formation of the sinkhole, identify the root causes, and take the necessary actions against any non-compliance under the Building Control Act and regulations.
Mr. Chi added that BCA engineers have been on site working closely with National Water Agency (PUB) and the Land Transport Authority to conduct thorough checks on the nearby buildings, roads and infrastructure. This is to ensure they remain structurally safe now that ground situation at the incident site has been stabilised. PUB says it has completed the refilling of the sinkhole using liquefied stabilised soil material, or LSS. It says safety is its priority as it works to restore the affected area.
We have started to test the ground with 3 different methods. The first method is ground penetrating radar, which we have deployed earlier. This round of tests will help us to check the ground one more time and to ensure that the sinkhole has been completely filled with LSS. The second method is ground probing method. Essentially, it's an insertion of a long metal rod to exceed 20 meters in this area to test the competency of the material. This is also to rule out any presence of void in the ground. The third method is a seismic survey, which will use sound wave to scan the whole area, which will give us a good profiling of the ground to a greater depth than the GPR. Collectively, these 3 methods will give us a good sensing of the competency of the ground in this area and to ensure that the ground is good for road construction so that we can safely open the road later.
Authorities are doing further checks for other sinkholes that may be forming at Tanjong Katong. They are using radars and probes to hunt for empty spaces underground that could cause the ground above to cave in. We look at how these tools work. Now, this is not a lawnmower, but a radar to scan the surface of roads. It can detect different densities of materials underneath. If low density is flagged, it means that there are soft spots that may be empty or filled with loose sand and water. But that's just scratching the surface. That's why PUB is going deeper. They are using drilling probes like this. It takes a sample from underground as deep as 20 meters, and after that, experts can check soil quality and whether there is a chance that another sinkhole may form. Now, to shed more light on this, we have with us today David Ng. He's chairman of the Civil and Structural Engineering Technical Committee at the Institute of Engineers Singapore. Mr. Ng, welcome to Singapore tonight. Thanks for being here. So the failure of a Kazan ring, Mr. Ng, has been linked to the sinkhole at Tanjong Katong. Help us understand what is it exactly and its role, its function at construction and sewage projects.
Well, Kazan wall is actually a ring wall, a concrete ring wall that's cast against the soil to prevent soil and water from coming into excavation when the shaft is being excavated in layers while we're excavating downwards. So it's prevent water and soil from coming in.
How common is the use of these Kazan rings in construction and sewage projects across Singapore?
It's quite common that Kazan ring like this is being used to construct temporary shaft for us to construct the manhole for the sewage system, for us to access to the sewage, completed sewage piping for future maintenance.
So it is quite commonly used,
Yes.
especially in urban areas or reclaimed areas. Is that right?
Yes, correct.
Okay, so it is a type of box, as you said, a watertight retaining structure that allows water to be pumped out. What can actually cause it to fail then?
In this, for this Kazan shaft wall, there's 2 possibilities. There's 2 case scenarios that we can infer based on the information that we can observe from all the information that is made available now. So scenario 1 is that it could be that this Kazan wall cracked for a certain reason, and then when it cracked, some of the water and soil may leak into the excavation in the shaft area. When that happens, some of the soil that has actually been washed in, that will left a void behind the K-zone wall. So that void may slowly eventually grow big enough and when and also shallow enough to the surface. And when the road surface is too thin that it's no longer able to take any loading, then when the car went on it, it will just cave in. So that's one possibility. But there is also another possible scenario that a void might have been formed next to the shaft, next to the K-zone wall shaft. So when this void could be formed by other reasons such as water pipe leakage that has actually washed away some of the soil material with it, and therefore it formed a void, and this void again slowly grow in size. Eventually, it may become big enough. So, based on the information that we have heard that the K-zone wall crack and the sinkhole occurrence is almost at the same time.
Yeah.
So that makes us to infer that it could be that the sinkhole, the void underneath the road might have already been formed, and the K-zone might be subjected to some unbalanced load condition because one side there's soil, but the other side is a void.
Okay.
So as a result of that, the K-zone wall might have been pushed sideways, and therefore it cracks. Yeah.
Between these two scenarios that you just illustrated to us, which one is likely the possible situation that may have led to that sinkhole incident?
My personal view is that it could, the second scenario is more likely.
Second scenario.
Yes, because for such a size of a void, it couldn't be formed within a short time. So it must have been formed earlier than when the crack in the K-zone is being observed. So there must be a void already formed, and therefore causing the K-zone to be subject to unbalanced loading, and then it is therefore overstressed and cracked. Yeah.
Is this something that could have been avoided, and could the consequences have been worse, you think?
In such a shaft construction, which we have done many in the whole Singapore, usually there are a lot of mitigation measures being implemented from the design stage up to and all the way to the construction stage. So from the design stage, we will investigate the ground thoroughly to understand the ground condition. So if we know that it's a challenging ground, as what we understand for the site here, which has sand and loose sand and maybe also soft marine clay, we will have additional protection for during the shaft construction. For example, we will do additional row of ground improvement column. It's like piling, but we will do all this pile all around the shaft first before we start to excavate down to cast the K-zone wall layer by layer down.
Sure.
Yeah, so that will actually prevent soil from coming in, soil and water from coming into the excavation during the excavation itself. So that this will prevent a void form outside the shaft and therefore lead to sinkhole eventually.
You think that was missing in the ongoing construction?
I'm not saying because we don't know whether this is done or not. I'm just saying usually this is normally done when we are in a challenging ground condition where there's a lot of threat of water and soil coming into the excavation. We will do additional layer of protection when we are doing the excavation. So these are during design stage. So during excavation stage, construction stage, we do have a lot of measures and monitoring on site for all the shaft construction like this. So we will have instrumentation on ground, such as ground settlement marker to monitor the ground settlement. And then we also have inclinometers to monitor the vertical soil, horizontal soil movement. And then we also have some piezometer, which is to sense the water pressure changes. So all this will be monitored on a very frequent basis during the construction to monitor what's going on site, assess the behavior of the ground. So all this will give us early telltale sign. For example, if there's a big void that has formed, right? Definitely there will be some settlement around in the surrounding that we'll be able to detect from these instruments. And then if we've seen it early, understand it, and then we should be able to implement necessary measures to mitigate the risk of a sinkhole formation.
As we know, Mr. Ng, Tanjong Katong is part of a swathe of reclaimed land, right? Can we expect more Ks and rings in construction projects under land reclaimed from the sea?
Well, we still have many reclaimed land in upcoming and also the existing area. One of the common way to construct such, we still need to construct our sewage system to serve the new residential area, new commercial area. So such construction of sewer shaft is definitely necessary. And construction by such K-zone ring is, to me, is perfectly fine. We just need to ensure that we have put in the necessary thought into the design process and assess the site condition carefully. We also do a lot of so-called impact assessment to assess that when we are doing such construction, what will be the movement that we will cause to the surrounding building, utilities, to ensure that such movement, the design must be done in such a way that the movement to the surrounding building, utilities must be, the movement must be minimized to a certain extent that it will not cause any damages to the building and the utilities. Then the design is considered buildable, then we will build it.
Okay, we hear you. Very well explained. Well, Mr. Ng, stay with us as we hear from residents living near the Tanjong Katong sinkhole. They say the safety of their neighborhood is the top concern. Sabrina Ng spoke with some of them.
Many of the residents I spoke to voiced their concerns about how the sinkhole could potentially affect the surrounding roads in this area. Some also recounted to me about the horrific events that occurred the night this incident took place.
当天晚上停水了，但是就觉得没有水的话会比较的麻烦。但是政府的话有提供生活用水，然后这一块会解决的比较好。
我是刚从地铁下来，我看到这边有这个地方3辆警车，那边都给截起来，我们都不能靠近，我们不知道发生了什么，但是我们觉得肯定是个大的事情。
Some residents who live in surrounding condominiums say they are not too worried about the sinkhole as they live some distance from it. But some are concerned of the lady driver whose car was swallowed by the sinkhole.
The way the car entered into the sinkhole, I was wondering whether the passenger was safe.
We were just praying that she'll be okay, and we're glad that she's all right.
CNA understands that One Ember, the condominium next to the sinkhole, will appoint independent engineers to assess the safety of its grounds. I spoke to some of the managements of the other condominiums in the area. While some are adopting a so-called wait-and-see attitude, others have already taken action. Discussions are in place for some other condominiums on whether they should hire third-party contractors to assess the safety of the area.
Now let's continue the conversation with David Ng, Chairman of the Civil and Structural Engineering Technical Committee at the Institution of Engineers Singapore. So we've heard the concerns from residents there, Mr. Ng. What is the chance of another sinkhole happening elsewhere in Singapore?
Like I said earlier, when we do such construction, there are a lot of measures that has been put in from the design stage to mitigate all the risks of causing excessive settlement or a sinkhole. And we also, during construction, we also have a lot of monitoring instruments that will able to actually tell us early telltale sign that whether there's any unusual ground settlement that will lead us to investigate further whether there's any potential void that has been formed underground. Then we will do further investigation, such as doing radar scanning or carrying out probe, just like what BCA has actually started doing now. So let's start from the current location of the incident. So where the sinkhole occurred, normally there is an influence zone that is more critical, that will be also have some ground movement because they will be moving towards where the cave-in is. So such area which is what we call the influence zone, will be subject to more detailed check. That's what BCA and PUB are doing now. I think as long as we need to ascertain that there is no further void that is hidden underground. Maybe some void may be quite deep underground, but such void is still a risk because it may eventually propagate upwards and eventually another sinkhole may happen. But so from what we are doing, I think what we see that BCA and PUB doing now, they are already covering the influence zone to ensure that no such case no such void or anything will be still there underground. So if the influence zone area has been secure, the area outside the influence zone is actually less of concern because that area under the soil mechanics condition, right? If only the soil within the influence zone is likely to move, but other than that, the movement will be quite minimal. Then talking about all other such similar construction work, whether it's in Tanjong Katong or it's other areas of Singapore, I think we are in safe hand because, as I said, we really have many mitigation measures implemented from the design stage to the construction stage to mitigate such risks of sinkhole. Because when we are doing the design for the sinkhole and we are planning for the construction, the first thing we have in mind is to prevent excessive settlement, is to prevent unnecessary damage to the adjacent property. So we need to do a lot of protection measures where we need to protect the excavation to prevent soil and water to come in that will lead to a void and eventually sinkhole. So then we have monitoring to tell us that if there's any unusual settlement. If there is, we will carry out immediate mitigation measures to basically eliminate the risk of sinkhole.
Okay, thanks very much for that. Very much assured now, Mr. Ng. Thank you so much for coming in tonight. That was David Ng, Chairman of the Civil and Structural Engineering Technical Committee at the Institution of Engineers Singapore.